5 times 5 is?
25.
Yeah. Hey folks, welcome, and welcome out there. You know what time it is? It's Mathline time. I'm Ernie Roberts. I'm your host today. Hey, just apologies for us not being around yesterday, but we had a little bit more weather-oriented problems over here in the east side of the state where we film, and we had some issues with getting crew in and out, especially being a little cold and wet and all that good stuff last night, and icy, very icy, so we didn't want to put anybody in danger. So thank you all for your patience and all, but we're going to make it up for you today, okay? Because we're here, we're live, and we want you to give some calls, all right? 844-686-2378. That's again, 844-686-2378. So let's make up for it tonight, all right? We have a lot of good calls, go wall to wall, work some math problems out here live on the air. That's what we're about here on Mathline, and it's up to you guys. Give us some calls, all right? Let's make the show rock this evening. Speaking of which, we're going to go back to problem of the day, like we always do, all right, this beginning show. And there it is. And by the way, this is today's problem of the day. Some of you wonder, where are we going to get yesterday's problem of the day in? We'll get around to it. Those of you hanging out on Facebook, just be patient, all right? But let's take a look at this one. A hemisphere has volume of 18 pi cubic centimeters. That's a half a sphere, by the way, a hemisphere. What is the length of its radius? So we've got 18 pi cubic centimeters. That's because it's volume, got to be in the cubics. And the length of the radius we're going to look for. So let's take a look at this one. There is a great thing called a formula that we're going to go to. And then we'll eventually get to the calculator. But our formula for volume of a sphere, let's start off with it. 4/3 pi r cubed. Because you say, well, Ernie, why are you going with the sphere? Because a hemisphere is going to be what? 1/2 of that. So here we go. We're going to take 1/2 of the sphere. So we're going to go, this is the volume of a sphere. We're going to go for the volume of the hemisphere. And we're going to take 1/2 times 4/3 pi r cubed. All right, so what happens when we take 1/2? Well, guess what? We're going to get a little cancellation action going right there, which looks like our volume of the hemisphere actually is 2/3 pi r cubed. Now, folks, does that make sense to you? Because we basically had 4/3 and we're going to take half of it, so guess what half of 4/3 would be? 2/3. But just to get you a feel for it, it didn't just come out of the sky, it wasn't just pie in the sky, no pun intended there. It comes in that way, all right? It just comes right out of the fact that half of 4/3 is 2/3. Now, we've got a formula. You say, well, Ernie, what are we going to do with it? Well, what are we looking for? We're looking for the length of the radius, and we do know the volume. We know the volume is 18 pi over here. So let's go ahead and set this thing up. 18 pi equaling 2/3 pi r cubed. Now, let's just take this thing piece by piece. You know and I know that I hate to deal with fractions, all right? So we're going to use the value here of 3/2. We're going to run the reciprocal through, and that's going to put us in a way that we can at least lose our fraction there, all right? So what's happening here, we drop a 1 underneath that 18 pi, like we like to do, and we can see some things working out very nicely here. So let's check it out. First of all, we have the 2 going into the 18, I believe 9 times, and we have 3 times 9, which gives us 27, and we have a pi that's hanging on for dear life here. Now what happened with the 3 and the 2, 3/2 over here, and the 2s and 3rds? Oh my goodness, all of them are canceling. That's why we chose that, all right? So we picked that to get that to work out for us. Now we have an equals, and we got pi r cubed. Getting close. And what's nice, we don't have any fractions right now. Yeah, everybody says that's good, that's good. So let's do the next step. We're going to divide it out, the pi, right through here, and say goodbye to pi, goodbye to pi. You say, well, Ernie, what just happened? Well, remember, we're trying to figure out what r is. Pi is the same value on either side, so it just basically divides itself out. Nice little division property of equality, and the power of 1 going on there, all right? When you get those to basically go to 1. So now we're down to a much easier thing to look at. We got 27 equaling r cubed. And some of you are going like, ooh, cubes. Because we think of squared a lot of times. That's what we talk about area, but here we're in cubic units because of, well, guess what? It's 3 dimensions here. So at this point, we're going to take the cube root. And by the way, some of you may not have seen us use this before, but we put a little 3 down in there, and we're going to cube root both sides there. And that's going to give us, well, what is it going to give us? Looks like it's going to be 3. Because what? 3 times 3 times 3 catches, 27. There you go, 9 times 3. So there you have it, 3 to the third. And it looks like r cubed. Well, if we cube root that, we're just going to take it down to r. That's the idea. So there is your radius. I believe that is in centimeters. All right. So we're going to have the radius equaling 3 centimeters. And let's go and see, did it work? My goodness, with all this starting from the beginning, basically if we go back and put in 2/3, and we have our pi, and we have our 3 to the third power, do we get 18 pi? That's the question mark, big question mark. Inquiring minds everywhere wanting to know, is it going to work? Of course it'll work, we hope so. Hit that 3 to the third, we know it's 27. So we got 18 pi here, equaling 2/3 pi times 27. I'm catching the 3 and the 27 doing some good things, so it's going to give us a 9. And you know what that's going to be? 18 pi to the left, 18 pi to the right, checks out. Our final answer works well for us. So a lot of thinking going through this one, I know. First of all, we start with the formula. We get the 2/3 going, and we use some fractions. Now, somebody said, Ernie, could we have gotten the pi out of there to begin with? Absolutely. You could take the pi out right off the bat, and you would have had something that looked like what? You would have had 18 pi equaling 2/3. Well, you would have lost the pi, right? You would have had 18 equaling 2/3 r cubed. And at that point, you can work from there to get rid of the fraction again. It's, once again, I chose to remove the fractions because we don't really like those very much. Get them out of the way first. Then the pi's disappear very nicely. So there you go, problem of the day. And let's get some problems going here, all right? Live on the air today. We want to hear from you. 844-686-2378. Again, get those calls coming so we can get the show rocking, okay? It's all about you guys. And like I said, all over Middle Tennessee, East Tennessee, Western North Carolina, Western Virginia, even Southeast Kentucky and Central Kentucky. We want to hear from you, all right? Give us some calls today. And let's talk about another feature that we've gotten. Facebook kind of gotten a little bit jumping on this. Those of you who are on the Facebook business there, you know what I'm talking about. We have the problem of the week. So let's take a look at that while we're waiting for some folks to call in. And what we've been doing on these problems of the week, folks, we do a little bit, we work a little bit here, work a little bit there, add some little stuff here, there, what have you. The catch is when we're looking at these problems of the week, well, they take a while, all right? So we add a little layering day by day. So which is the better buy, a large pizza with an 18-inch diameter for $15 or a medium pizza with 14-inch diameter for $9? Again, I think Monday I mentioned the fact I think that 18-inch diameter sounds to me kind of like that would be an extra large and the medium maybe should be a large, but you get the idea. We've got 2 pizzas and they are definitely of different size. And if we go to what I've got going here, let's see what we have done so far. We have said we're going to need to use area because we're talking circular pizza, all right? We're talking the word diameter popping in there. So we are going with the pi r squared. So let's go back to that a moment. Pi r squared, and then a good old pi r squared. Now, why did I do it twice? Because we got 2 pizzas. One of them has a radius of 9 inches. Now, notice this is not about diameter squared, it's about the radius squared. So we got to use 9 squared times our pi, which is going to give us 81 pi. That's going to be the area of the large pizza, the larger of these 2, all right? The other little guy is going to be pi times the 7 squared, all right, which is going to give us 49 pi. Now, as you can tell, I hope you can, this one obviously has a lot more square inches of pizza than this one does if you look at the surface of it. Now, of course, there's also a little bit of depth that we're not going there. We're just going to consider they both have the same depth, so we're working on basically it's either what would it be, a deep dish or a regular pizza. It's immaterial in this case. We are looking to see who's going to have the better price. Now, one more hint that I'm going to give you, why do we have to know that? Why do we need to know that? Because we are going to divide this amount into the money. We want to find out how much is it per square inch. And I'm going to leave that with you. We'll figure that one out tomorrow. We'll add that to the mix and we'll solve it out and see who wins out. Now, if you're following us at home, take care of business on it. Go ahead and figure out where we are. And it might surprise you. It might surprise you on these. These numbers are pretty interesting the way they work out. So give it a go. And the idea also is then how much less is the better buying, all right, per square inch. Ha! We'll find out. We'll find out. Now, what we're going to find out is how are we going to do with calls? We'll get some calls coming in here. We hope we will, all right? 844-686-2378. Chilly outside. It's warm inside. Let's make the show rock, okay? And have a good time with it this afternoon. In the meantime, I understand we do have a, Hey Mathline? Waiting for us? Let's go for a Hey Mathline here while you folks are waiting to call.
Hey Mathline, I am Sawyer Shepard from Powell High School in Powell, Tennessee. How many ways can a person take 10 cards and make a hand of 5 cards with no repeat combinations?
Sawyer, that's a mouthful. Thank you, Sawyer from Powell High School. Sawyer Shepard out there. How many ways can a person take 10 cards and make a hand of 5 cards with no combinations that are repeating? And we're going to say those are 10 distinct cards, all right? And the 5 cards that we're pulling out have no repeat combinations possibility. In other words, just because you get, let's say, an ace of spades, the first, in one hand you get the first and you get 4 cards, and you get the same 4 cards and you get another ace, you get the idea. No repeat combinations, all right? So that 5th one would be the ace of spades, maybe, possibly. It doesn't matter where they come, all right? In this case, it's just going to be the matter of fact that we get a combination. Order is not important, which those of you who are thinking about, that sounds like he's talking about permutations and, combinations. So let's look at this thing. How many ways can a person, you start with 10 cards and repeat combinations? That is telling me we're going to use the formula for combinations here. And how do we do that? Well, let's see. The deal is basically we're going to say 10 taken 5 at a time. That's a nice notation, all right, with the C being combination, all right? So we're taking 10 cards to start with. We're picking up 5 at a time, and the idea is how many ways can we make that hand of 5 cards with no repeat combinations? So talking it through here, there is a formula. There's a formula. And first of all, it's going to be, well, let's just go back to, let me not put the numbers in here yet. Let's suppose I have N taken X at a time, all right? And we got the C here. So here's how the formula works. We take this value right here. I was about to throw it, I'm about to give it all away there. We got N with the factorial, and we have, underneath, we have X factorial, because that's the amount we're taking, 5 at a time. But we also need to take in consideration that we have possibilities of also, we're going to need to divide by N minus X. So N minus X, that would be, once again, that would be 10 minus 5 in this case. So let's see how this is going to look. This is going to give us 10 factorial. It's going to give us 5 factorial. Oh my goodness, and another 5 factorial. And you say, well, Ernie, where are you going to go with that? And by the way, what is this factorial business? What does that mean? So 10 factorial means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 out to 1. So in other words, you take every number, including that, all the way down to 1. You obviously don't want to go 0 because everything wipes out. So that's what the factorial is about. So in case you're looking at it, this is going to be 5 factorial, and this is going to be 5 factorial. Now some of you are going like, whoa, that's a lot of things to do, a lot of multiplications. Well, let's see if we can make it a little easier. We're going to pick up 10 times 9 times 8 times 7 times 6, and I'm going to put out here a little 5 factorial. Underneath that, we've got 5 factorial times another. How about it? 5 times 4 times 3 times 2 times 1. Notice what I did. I basically said, okay, 10 times 9 times 8 times 7 times 6, and I cut it off there. We got a 5 factorial. That takes care of the 5, 4, 3, 2, 1. Because what's going to happen is these two guys are going to cancel out. And now all it's leaving me with is 10 times 9 times 8 times 7 times 6. Let's go to the calculator and figure that one out, all right? So we got 10, we'll hit it times 9, times 8, times 7, times 6, and we got a number. It's goodness sakes, it's 30,240. I'm going to take that right down there. Now you say, well, Ernie, what's that 5 times 4 times 3 times 2? Let's see if we can get that one in our head. I think we can. I can say 5 times 4, which is 20, times 3 gives me 60, times 2 more gives me 120. Now what we're going to do is go back to the calculator, and we're going to divide this thing out, all right? We're going to take this thing and divide it by 120. And there we go, 252. So it's 250 options. If you're dealing out 10 cards, there's 252 ways those things can fall with no repeat combinations. That's a pretty impressive number. And by the way, when we use these formulas, they have to come out even, because you either have a combination or you don't. You either have a hand of cards or you don't. So these are going to come out nice whole numbers. So if you get something funky on the calculator, like a fraction there, something is amiss. Calculation of some sort. Okay? So Sawyer, there you go. A little bit of a look at your probability and statistics moments there, all right? Understand, speaking of which, we've got a caller waiting for me on the line. Welcome to Mathline this afternoon. Who am I talking with?
JC.
JC, how are you doing today?
Good.
Good. Where are you calling from?
Cookville.
Cookville. All right. What kind of problem have you got for me this afternoon? Okay, can you come back again on that? I think I just lost your voice a little bit there.
88 times 77.
88 times 77. All right.
Yes.
Now, are you used to spreading it out like in the box manner?
Yeah.
You're used to doing that? Well, let's go ahead and do that. In other words, you're saying basically so we're going to take 80 plus 8 going here, and then a 70 plus 7.
Yes.
And let's see what happens when we multiply it out. Then I'm going to do it the old-fashioned way for some of our viewers that like the old-fashioned way also, okay? We're going to group this thing out into a nice little box effect, and we're going to add some results together. And that's basically what we do. We do 4 multiplications,
Okay.
and we come up with the addition, okay? And then we also do the same thing when we put them separately, okay? So here we go. We're going to say 80 times 70. And 8 times 70 gives me what? 56, and I have 2 zeros, right? So far, so good. You with me?
Yeah.
Now I'm going to play the same game here. I'm going to do 70 times 8, which is going to give me, well, still 56, isn't it?
Yeah.
But it's going to be what? 560, okay? Look what's going to happen here, JC. We're going to have 7 times 80, which guess what that gives you? 560. And last but not least, this seems like a 56 problem, doesn't it?
Yeah.
So what we'll do, we'll take 5,600. We'll take 560. I think we just lost her. 560, and we'll finish it off here. And we just add those lovely numbers together. We go right down the line. We got a 6 on the end. And we have a 7 here, I believe. 12 and 5 gives us 7. Carry that 1. 7, 12, and 17. And we'll run a, what do we got there? 1 going up here. So it looks like 6,000. Oh, that's kind of interesting. A little palindrome going there. 6,776. Now, I said I'd do the old-fashioned way. That basically it's the same story. It's just we run our multiplications vertically. And we do a little fun with them. So we've got 8 times 7, which gives us 56. Place a 5 right up there. 8 times 7 is still 56. Not going to change this game. And add 1, we got 16. Now we do the same story here. But we're going to bump it over a little bit. We're going to go to this 7, and we're going to bump over, and we're going to put a 6 right there. It looks like the same story again. 61. And look what happened. It basically did the same thing. It was just spelled out in a different way. We still did 4 multiplications. We added the results together. Again, just another way to come up with 6,776. Which way is the best way? Depends on what your teacher's asking for it probably at that time. But also the fact is, this helps you see where it all is. It's really 4 multiplications. Yes, it's still 4 multiplications here. We just do the little addition and carrying all at one time in the problem rather than waiting till the very end and doing all the additions. So Either way, we came up with the same problem, same answer, and there you go. JC, thank you for calling in on that one. Appreciate it, all right? I understand I have someone else waiting on the line to talk with me. Welcome to Mathline. Who am I talking with this afternoon?
Hello, this is Anthony from West High School.
Anthony, how are you doing today? Good to hear from you again. West High School in Knoxville, right?
Yes.
So we got a Knox County person calling in. We appreciate that today. What can I do for you, sir?
Well, I've got another equation.
Okay.
The equation is y equals 7x plus 8, and x equals negative 3x plus 8x equals 23.
Okay, so hold on just a second here. I've got y equals 7x plus 8.
Yes.
Okay, and what's your other equation?
X equals negative 3x plus 8x equals 23.
Okay, negative 3x plus 8x
Yes.
equals 23.
Yes.
And you're looking for an x and y to work together with, right?
Yes.
Okay, so here's what's, is this a plus 23 or equals 20? It can't be equals 23 out here. We got too many equals. Is it plus 23 or minus 23 on the end there?
It's minus, sorry.
Okay, got a minus 23 out here?
Yes.
All right. Okay, let's see where this is going to take us. Is it definitely, it's a 23 there, huh? We're not going to have a pretty value there, but that's okay. We are going to do this. We're going to get x, and we're going to equal to, looks like 5x here. You see where I'm going on that? Put the like terms together, and then we'll subtract 23 right there. All right, so far so good?
Yes.
We need that 5x to move over to the left, but we don't want to make it go over positive. It's going to have to go over negative, isn't it?
Yes.
Because we got to subtract. So whatever we do to the right, we're going to do it to the left.
Yep.
And that's going to give me negative 4x equaling negative 23. And I said this doesn't come out even, but it's still not that bad. We can figure this one out. But we're going to divide both sides by negative 4. And this one gives me x equals, and this one is actually going to go in evenly with the decimal. And I'm assuming it's okay that you can use a decimal, right, for your value?
Yes.
Okay. So it looks to me like this is going to go in 5 times with 3 left over, 5 3/4. And it's going positive, right, because you got these two go positive when they divide, right? Negative divided by negative. Yes. So I'm going to use 5 7/75, or 5.75 there for your x. So far, so good?
Yes.
Now, let's go over here and see what the y is going to give us. 7 times, because now we have an x that's got to go in there, times this 5 3/4, okay, plus your 8. And I'm going to take to the calculator just a second on this one, okay? Let's see what happens. Clear all that other stuff out that we were doing. And let's take 7 times 5 7/75. And according to this, we want to do, we want to add 8, right? You did have a plus 8, I believe.
Yes.
And I'm getting y equaling to 48 1/4, okay?
Yes.
Which makes sense that we have fourths here and fourths here, because it was nice when we plugged the x in there. It basically is not going to mess you up in that regard. So this was 48 1/4 if you want to play fractions. This one is 5 3/4. And again, just the big thing is, in this case, you've got to find x in order to get to what? Get to y, correct?
Correct.
You see that? So we take this one, and then we bring it right in here and plug it in there, substitute, and see what it gives us. And if our calculator hit the right, if I hit the right buttons on the calculator, do you agree with me we're okay on that?
Yes.
So I think we hit the right buttons there. That's the only thing about a calculator, that sometimes you hit the wrong buttons, but looks like when I look back over there, it looks pretty good. And the 5 3/4, again, it's nice because it's a decimal. It works pretty nice. Okay? Does that do for you?
Yes.
All right. Thank you for calling us there. And since we, before we leave there, I want to look at just one more thing here. Just go back and you can do a quick check on this part right here to make sure your x was good, because, hey, we do not want to end up with a bad moment here, right? So we'll put in that, and I'm going to go ahead and go to the 5x because I know we did that part correctly. 5.75, and then we'll subtract 23. I'm going to go back to the calculator. Trust my calculator on that. And plus the fact I understand we've got a short time here left to go, so want to jump that in there pretty quick. And then we add 8 And yes, we get 36.5. I'm sorry, we need to take that back. Let's go clear that. Let's go back to 5 times. I got the wrong, I mixed up things there. Sorry, folks, hang on. 75. We want to subtract 23. That's much more reasonable. Yes, and then we were supposed to come out with 5.75 or 5 75/100ths on both sides. Now that works. So again, sometimes you got to think a little bit, get in the motor process, but always catch yourself if you make a little error there. And again, folks, thank you for tuning in. Thanks for the calls. JC, Anthony, appreciate you calling in today and work through problems. And tomorrow we'll be back again, do some more live problems on the air. Reminder, Specialized Segments is coming up Friday. I think you'll really enjoy that. It's all about chains of logic and other good things. But tomorrow, it's a call-in day, and we hope to see you then.